All right, welcome to part 2 of SRS systems. We left off with this imaginative yet unpractical innovation of pedestrian and SRS systems. And we talked about how hood ornaments are gone because of impaling pedestrians under collisions. So moving on. Remember, as we mentioned before, disarm airbags before servicing related parts. This may include waiting up to 10 minutes for capacitors to discharge, and capacitors are basically little components that quickly store and discharge electrical charges. They don't create the charge, they just quickly store it and discharge it, so they could be deadly. So you want to follow manufacturer procedures to deactivate the system and drain the capacitors, and that could include, again, removing fuses and waiting up to 10 minutes, depends on the manufacturer, but that's basically the gist. Use torque wrench to torque sensors and modules. Loose sensors can give false acceleration readings. Tight sensors can distort some of those sensors we'll talk about later. They'll distort the plate. That can affect impact sensing. Do not use air tools near sensors. Live airbags must be deployed before sending back. That is basically for like recalls if you have to ship them, etc. So driver side airbag, most of you are familiar with that in the steering wheel area right here. There's a seam that's designed, a weak link to open up for the airbag to come out. The multi-stage, as we mentioned earlier, uses those two squibs to control the rate of inflation. Minor accident, only the one, basically the 40 squib is deployed. You can do the second squib, the 60 and up to 100 depending on the system, on how that works. But here's a picture of that squib. Here's your inflator, the igniter right here, and then you have all the explosives right there. So in high-speed deceleration, 60 and 40 charges are used for full occupant protection. Here's your two stages. And again, it depends on the system on how they deploy that. Some systems are strictly 2. Some I've seen 3. Old ones were 1. It all just depends on the manufacturer and how they engineer it, I guess. So here's your passenger side and that split seam of the airbag where it's going to kind of weak link come out of there. Something to think about or know about passenger side. Move this down a little bit. There it is. They're much larger than a driver's side. They have to go a greater distance. Passengers are usually further away from the dash than the driver. They deploy with the driver's side airbag on most systems. Some systems have cutoff switches, like pickup trucks where there's no back seat. Could be an add-on kit, but you don't see that at all. Not many manufacturers want to modify the system for liability reasons. But most new vehicles either have a sensor or a switch that can turn off the passenger side airbag. But these are on vehicles that don't have a back seat. So if you had to transport a child in a car seat or even just a front seat, you can turn off the airbag so it doesn't injure the child. Again, it could be manually. You can put a key inside there. Sometimes there's sensors that have to be calibrated, weight classification systems. Some of them use electromagnetic fields with child leaning against the side. It could be seat position, could deactivate it. Again, a lot of them have the ignition key goes into a slot and turns to turn off the airbag for one trip, and it defaults back on the next trip. It just depends on the manufacturer design. Here's where you have your PAD or passenger airbag deactivation lamp, whether it's off or on, and that tells you right there on the dash somewhere, and usually near the key on a Ford system like that. Here's your side airbag on the seat, so it actually comes out of the seat. The seat stitching is designed as a weak link to rip open for that bag to come out. So think about this if you have seat covers. Make sure your seat covers have a weak mesh on the side that can be ripped in the event of airbag deployment. Otherwise, that airbag can't come out and it's going to push the back right here and can cause damage and injury there as well. So make sure your systems work together with that seat cover. Then you got the curtain again we mentioned earlier, comes out of the headliner. This picture is cool because it shows you the deformed headliner as that big long tube across this curtain up here. The A all the way to the C and sometimes the D pillar on SUVs will have airbags come out off the top there. They'll have a squib at one end and it explodes down a rail and it pulls this curtain down to protect the occupants from the pillars and glass, etc. A little extra cushion. So some of the components I shall see, this is that yellow tubing I mentioned, the convoluted tubing or tape harness. You'll have the airbag right here, crash sensors. You'll have this right here, the clock spring, where all the wiring goes through, or cable reel, they're called both things, goes through the steering wheel up to this airbag, how it connects right here. That allows the airbag or the steering wheel to turn without getting binded up. Here's what's known as like a restraint control module. This is what's actually monitoring the sensor input for collision. And when it detects a collision, It's going to send out signals to either deploy airbags, the seatbelt pretensioners. It can be the whole system can be integrated like on modern vehicles with braking, collision mitigation. It can activate brakes, turn on hazards, call 911. Some of these systems get very complex and intricate today. So basic older systems were like this. They just deployed airbags based on inputs from the sensor. So that RCM, Restraint Control Module, also known as a diagnostic module, monitors all those sensors, including crash sensors, seat weight position sensors. It'll let the computer know if there's a passenger up front that's lightweight and turn off that airbag or what stage to deploy it at. So basically here's that RCM, Restraint Control Module, diagnostic module. Note that it's mounted directly to the body of the vehicle for structural rigidity, so it can measure that deceleration rate, or as yaw rate sensor can tell if a car is rolling over, yaw, or it's understeer, oversteer, steer, rollover, etc. And note the arrow shows mount direction because you'd have to put it in the correct orientation for it to monitor that information. So diagnostic module self-test. When the key is turned on, the SRS module performs the following checks. Checks reserve power from capacitor, make sure it's good. And that capacitor is there to deploy airbags in the event of the battery becoming disconnected in a collision. Like if you're rolled over, let's say, right? Checks bulb condition, make sure it actually tells the driver whether or not the system's faulty. Checks crash sensors for shorts, opens, or grounds. Checks airbag resistance. It actually will check the resistance of the circuit through the squib. If all that's okay, system's active. And then if you do get in an accident, the system will either store DTC and information to be retrieved later by investigators or the technician, depending on what happens with the car after collision. Insurance might need investigation, so that information is saved, kind of like a black box, quote unquote. Also, it's going to store DTCs for all these deployed sensors and airbags. So sometimes all that has to be replaced, and the cost of that is so usually high that it actually totals the vehicle. Sometimes you may look at a car that's been totaled and you thought, well, it's not that bad, I can fix it. But the cost of all those airbags, crash sensors, restraint control module can quickly add up to the cost of the 80% of the vehicle cap that the insurance will allow. So a couple different types of sensors. Well, one we're going to talk about just real quick. Well, I should talk about two, but here's one. You think it's real complex, which is kind of funny. When I learned how I cut open one of these sensors, I kind of laughed like, yeah, less is more. So you have a bias magnet here, a steel shot ball, and under a certain deceleration rate, the steel shot ball gets dislodged from the magnet. It's very calculated, and it's going to make contact across these electrical contacts, and that sends a signal to the restraint control module, diagnostic module. So as you can see, the arrows are obviously critical for that dislodging to occur under deceleration, not acceleration. Pretty cool. More complex systems now have a piezoelectric element that deflects under collision, and that deflection sends an analog signal to the computer indicating the severity of the crash. So as this wafer kind of deflects and bends, it'll create a variable analog voltage. And that signal is used by the airbag control module to determine what rate to deploy airbags. And of course, there's multiple sensors coming in. How the weight sensor of the passenger seat, the impact severity, what the car is doing, the speed, the load, etc. Side impact sensors, much like those front impact sensors, but they're mounted in the B pillar, C pillar. They could be down on the floor. Senses side impact and begins that process to inflate seat and side curtain airbags. So they don't all deploy the same crash. Depends on the severity and angle of the crash to deploy certain airbags or not. Here's your seat weight sensor. So again, in that passenger seat, that passenger airbag, if you have a small child or person sitting there, you wouldn't want a full deployment of airbags. So there's a occupant weight classification system, a little fluid bladder that you sit in, or there's just sensors on the track like this right here to determine the weight of the person in the seat so they can deploy the airbag at the correct rate. We also have this E-field sensing kind of newer technology where to tell if you're leaning against a door, it's not going to deploy the side airbag or the door side airbag on the torso side of this airbag here. But as technicians, to make sure these systems work, I always like these plastic butt cheeks. They're a special weight. You put that in there, you hook up your scan tool, and then you can determine is a sensor gauging the correct weight. And then, of course, these are calibrated at a specific weight, and you can look and adjust accordingly to kind of set them back up to the appropriate cut point. So another thing the techs do, Never thought you'd do that, right? Put a plastic butt on a seat and program it, but here you are. So basically, typical airbag deployment sequence. After the crash occurs, the sensor contacts sends a signal to the crash sensor, and that sends out to deploy the airbag disclosure devices, which actually are super fast, right? Think about those videos I saw at the beginning, or that we watched at the beginning of this lecture, how fast that airbag deployed and then deflated right in front of your eyes. So basically, if you watch in the slow motion on those crash tests, when that vehicle hits impact at the wall or oncoming vehicle, before the passenger's head starts to lift off of, the occupant's head lifts off the seat, that airbag's already deployed and deflating as the head's hitting the airbag. It's crazy how fast this happens. And of course, all of this is gold plated for speeds, for the low resistance and corrosion. So pretty cool. That's basically it for supplemental restraint systems as far as this lecture. What I'm going to attach after these videos, you'll see some more demonstrations of some crash test rating systems and the importance of crash testing. So big key takeaways: wear your seatbelt, get your airbag, keep your seat not too close to the airbags, make sure your seat covers work with side airbags, and then understand the process to deactivate the airbag system if you have to remove those parts or recalibrate those sensors. All right, if you have any questions, go ahead and give me an email, and thanks for listening to the SRS Introduction Part 2.